Greetings everyone, my name is Arduino a student at Central University of Technology, and today I'll be demonstrating my Arduino based project. The name of the project is temperature, humidity and water level sensor for a poultry house. So here behind me I have a poster demonstrating how my project actually works. The first part of the poster is a brief description of my problem statement, my description of the project and own design, and the description of the part of the proposed project that is said to be my own. The second part is the block diagram of my proposed project. Third part being the flowchart, which simply guides how I'm going to write the coding or the program for my project. And the fourth part is the PCB of my project, which is followed by the schematic part of my project. And the final part is the research part of my project, which simply is a brief of how poultry automation system can be implemented in poultry houses to better benefit commercial places commercial places like farms or anywhere people sell chickens. The system will benefit the owners in such a manner that the poultry temperature systems can be automatically controlled to keep their inhabitants warm. The system will automate the water filling system to avoid having someone to constantly refill the poultry water. This makes it more affordable as there will be no need for labor or a caretaker for the chickens. Thank you. Okay, now moving on to the second. I'll first start by explaining my components and the functions of each. So now here we have our servo motor, which will serve as our automated window. The arrow simply shows just if the arrow is facing down, it shows that the window is closed, and as the arrow moves, it shows the level at which the window is opened. Here we have our LCD, which will display our needed information, and then here on the inside we have a light bulb, which will serve as a substitute for our heat source, and then we have our fan here, which serves as our cooling system, and then here we have our automated water system. Okay, so now moving on to the second part. The second part consists of two sections. There's the DHT11 temperature and humidity sensor part and the water level sensor part. So now we will proceed with the DHT11 temperature and humidity sensor part. We have three sections which are considered to be cold temperatures, normal temperatures, and hot temperatures. Any temperature that is below 27 degrees Celsius is considered to be cold. Temperatures between 27 degrees Celsius and 29 degrees Celsius will be considered as the normal or the desired temperature. And any temperature above 29 degrees Celsius, we will consider it to be a hot or extremely hot temperature. So now moving on to the circuit to demonstrate how the temperatures actually work. Here, if you look at the temperature, you will realize that the temperature is sitting at 23.6 degrees Celsius. So it is expected that the heat source should be on, our cooling system should be off, and the window should be completely closed. And that is exactly what we are seeing at this point in time. But then now that the heat source is on, you can slowly see the temperature slowly rising, and as soon as the temperature hits 27 degrees, then it is said to be a normal or the desired temperature. Therefore, we can expect in the normal temperature situation, we can expect that there will be no control mechanisms except the window being slightly open. The fan will remain off and our heat source will turn off. Our window will open partly. So we can see the temperature is slowly rising. It should be there in a second. So now we are at 26.6 degrees Celsius. As soon as we hit 27 degrees, it is said to be a normal condition or a normal temperature. And under normal temperatures, like I said, under normal temperatures, we are expecting the window to open partly, and the cooling system must remain off, which it is, and the heat source will remain off. We only have the window being partly open. And now the third part is hot temperature, which is any temperature that is above 29 degrees Celsius. So you can see the temperature continues to rise, and as soon as the temperature hits 29 degrees Celsius, we are expecting that the heat source will remain off, the window will open widely, and our cooling system is supposed to be on. So now we wait as the temperature continues to rise. We are at 28 degrees Celsius. Okay, just went back 28. So now we wait until we reach 29. Actually 29.1. Any temperature above 29 is considered to be a hot temperature. So now we wait as the temperature continues to rise. Since the temperature is slowly rising and going back, for the sake of demonstration, I'm going to introduce a hot air blower just to speed up the process. So I'm just going to put it just a bit close to the DHT temperature and humidity sensor, which in a minute you should be able to see the temperature rising from the hot air that it is receiving. There, as soon as we hit 29 degrees, our heat source remains off. Our window, our heat source here is still off. Our cooling system, I'm sure you can hear the cooling system. It is now on. And if you check the window, our window is now completely open, so that it allows the system to actually cool off. So now the temperature is supposed to drop steadily, and as soon as the temperature hits below 29 degrees, we will go back to a normal mode. And remember, back in normal mode, our cooling system is supposed to be off, our heat source remains off, and our window will be slightly or partly open. So no control mechanism other than the window being slightly open will occur. So we're at 29.2, 29.1 degrees Celsius. So if as soon as we hit 29, that is as soon as we reach 29, we are at 28.9 degrees Celsius, and it is set to be our normal condition. Okay, now everyone, so now we're moving on to the final and the last part of the project, which is the water level sensor. We're gonna start with water enough, and if you go to the drinking bowl, you will realize that the water is indeed enough. So now let's say that the chickens start drinking the water, so that we get to experience what happens when the water reaches a lower level. So according to the system, like I said, like I aforementioned, that as soon as the water level is low, the water module sensor will send a signal to the water pump that the water is too low, and the pump will continue to refill the drinking bowl immediately. So now the chickens continue drinking water, and we are about to reach the low level. So there it goes, water too low. So once it reaches water too low, it will continue to refill until it reaches the highest level again. And if you go back, you will realize that it has gone back to water enough. Thank you. That is the end of my project.